Hi, I'm Mariska Dreschler and I'm Director Horticulture of GreenTech. I'm here at Aquitech at one of the main exhibition halls, and here you feel the excitement to meet people face to face from all over the world, just like at GreenTech. Let me take you to Saudi Arabia, where under extreme climate circumstances it is possible to have sustainable food production with maximum yield and minimum usage of water. Are you curious? I am. Let's take a look together.
One of the biggest problems the Middle East faces is the shortage of water. The depletion of aquifers, which has been formed in millions of years, goes at a very rapid pace. The agricultural industry in the Middle East has to find new ways to grow their crops. We're here to talk about the research project Estidama, which has been designed by Wageningen University and BOM Greenhouses. Welkom, Mike Vermeij, CEO of BOM Group, and Jouke Kampe, researcher at Wageningen University.
Thank you.
Yeah, great you're here to talk about the Estidama project. First of all, you were both involved by building and the research of this project, but I'm very curious, who's the initiator of this project?
Well, Wageningen was the initiator of the project. It started already in 2009. Then I went to Saudi Arabia to present some plan or proposal to set up a research center in Riyadh. And well, it took a very long time because before it was really established this center, and that had to do because the ministry was not able to set up such a big project. But then fortunately SABIC came in, who is also a contributor on this fair here at the moment, and well, they took the initiative in the end, and they were basically the financiers of the Estidama project in the end.
But if I understand it correctly, Wageningen University initiated this project, but the problem is in Saudi Arabia, so that's kind of strange, right?
Yeah, that's strange, but well, here in the Netherlands we have a lot of water-saving technologies, and well, we knew already they would also be applicable in Saudi Arabia, but yeah, seeing is believing is very important for the growers there. So showing that these technologies really work also under their extreme conditions. So it was vital to set up a research center in that area, and basically that was the main motivation to set up the center there, to really demonstrate that water-saving technologies, which are already commercially available, can be applied in this extreme Saudi weather as well.
And why is it so important that there are these research projects in the Middle East? Is it because of the water shortage there is there?
Yeah, well, the main focus of this project was to really demonstrate this technology under the local circumstances or the local conditions, because, well, we knew these technologies would work, of course, but seeing it under those extreme temperatures, for example, up to 50 degrees, that is something, we really also had to see if it was working in the end. So that's why we set up this research center in Riyadh.
Because I can imagine that it's important to have these projects so they can build or have more production of crops there. Or is that the main reason? Because the population is growing in the world, so we need more food. That's like a clear story.
Yeah.
And how is it produced now there?
Are you talking about the actual produced now in the greenhouse, or how the Saudi in general now produce their production?
Yeah. Well, how they produce their production at the moment, and why it's so important that we have such research projects so we can produce more.
Yeah, shall I answer that?
Sure.
Now the current standard line in Saudi is to cultivate crops in tunnels, plastic tunnels, or in a greenhouse with a pan and van cooling.
Yeah.
That means that they use water as a medium to cool down the greenhouse, which is considered to the Dutch standards, it's low-tech or mid-tech. With those technologies, they are able to grow some production during a certain period of time in the year. Production is relatively low, quality is okay, but they use considerable amount of water to do that. I think the Saudi government said, okay, we need to show, not do research just for research, but we need to have a practical example of how it's done or how it could be done. So that's
for
why
the future.
For the future. I think in general that's not only for Saudi, but in general all over the world we are facing with the growing population. We are facing with less land being available. It might be a discussion point, but in my personal opinion, we have enough energy in the world to do whatever we need to do. The only shortage we have globally, even in the Netherlands, is fresh water, potable water. I think the people in the Middle East region are more aware of that. So they are looking for the technology. They sometimes have to be positively influenced by Wageningen University to think about, okay, how can you really solve it? How can we make the example to prove that it's doable? Not prove it here in the Netherlands, but prove it there in Riyadh.
So if we're not having such developments or such research done, how does the future of the Middle East look like in the next couple of 10 to 20 years?
I think they will face a lack of available potable water, drink water, fresh water. If they don't invest in technology to cultivate vegetables in the region, every country is looking for more local production, being less dependent on import.
Yeah.
Political, economical stability, it's always a challenge. If they don't invest in the technology, then the climate makes it very difficult to grow vegetables, unless you use a lot of water. And they will run out of it in 10 to 20 years.
So in 10 to 20 years it won't be possible with new techniques? Without new techniques it won't be possible to grow crops there anymore?
Already you see this development in Qatar and in the Emirates. They already depleted all their water resources. So there they already need desalination, so getting water from the sea, taking out the salt and use that in the greenhouse. But that's very expensive, of course, because it's basically drinking water what you are producing, but then you are using it to cool your greenhouse. Well, also to irrigate your crops, but to cool your greenhouse is the main use of water in these greenhouses. So finding alternatives, for the cooling basically, but also for the irrigation, because they are still growing a lot in the soil, so directly in the ground, and taking it from the soil and putting it to a substrate, for example, so that it's that the amount of water you give, you can exactly monitor how much you are giving and how much is depleted, but then you can recapture that water and reuse it again, so that also saves a lot on water. So all those technologies can really improve the water use efficiency in this region.
And actually it's necessary to make sure they can grow crops within 10 to 20 years.
Yeah, absolutely.
Exactly.
Okay.
Yeah.
Okay, and then so the project, you could start a project, and what was next? How did this cooperation started?
Well, we basically designed this center, which was built in the end. So we had indeed this standard technology. Then we had this mid technology, which is slightly more advanced technology from the standard technology, and the high technology, the high-tech technology, which is the most ultimate water-saving technology. So 3 technology levels were present in this setup, and basically we wrote the setup, so the tender document, which was then distributed to various greenhouse builders, of which one of them was BOM, and in the end BOM came into the picture because they could convince the client that they were the best party to establish the center in the end. Yeah.
So.
Lucky one.
Yeah, lucky one. That's great. And how did you start the development of the technique and building the project? How did this process go?
The whole process, as in a normal situation, when we receive a tender document, we first check out what's the request, what's the technology, is it technology that we know that we've done earlier, is it doable for us? And in this case, it was a challenging technical specification.
Why?
BOM Group is focused on glass greenhouses. So one part was we also need low-tech, which is a plastic greenhouse, which we had to cooperate with another party to be able to supply it.
Yeah.
But our focus was more, okay, we have the mid-tech, which is a normal greenhouse, which is provided into the region a lot. But the high-tech greenhouse, that's really high-tech. It's even more high-tech than the current standard Dutch greenhouses, because it's not even a semi-closed greenhouse, it's a fully closed greenhouse.
And that's completely new.
That's completely new. In the Netherlands it's not done. Why? Because we don't have the challenging climate that it needs to be done.
No.
It needs additional investment. Investment in technology means investment in money, of course, but also investment in energy. And in a moderate climate, that's not feasible. It's not needed. It's not feasible. But in a challenging climate, like the desert area or the arid region, there we are facing with extreme heats, with extreme solar irradiation, droughts, low humidity. There it's feasible to completely close the greenhouse, to have a completely closed shield between the outside climate and inside climate. And the parts of the technology that were described by Wageningen University in the tender, we were familiar with. We have used before. We had a good idea on how to implement it. So we included it in our technical quotation, in our supporting story, and we were able to convince the customer eventually that we have done parts of it before. We didn't do the complete greenhouse as it is, but semi-closed, more than enough. We had the experience, and they said, okay, you have a relative good price for a high quality, very high quality greenhouse. You convinced us you can do it, start building.
Yeah. And you started building, and the project is there.
Yes.
And the results are there as well, right?
Yeah.
Yeah.
Some of them.
Yeah.
Yeah.
We are now in operation for 1 year, so we have the first results, and they are very promising. So
for low tech, mid tech, as well as high tech.
All three levels of technology have been tested now. Yeah. Currently, we are also doing an experiment where we are really testing, comparing these three levels of technology. So we have placed tomato in all levels of technology, and we are just monitoring the water use, the energy use, the CO2 use, so basically all resources which are needed in the greenhouse operation. And after 1 year, so that will be in about 6 months or so, then we get all the data, and then we can really say, okay, if you produce in the low tech, it will cost you so much, in the mid tech it will cost you so much, and in the high tech it will cost you so much. And currently I can say, the mid tech for the Riyadh region looks most promising. It saves, it saves about half of the water compared to the low tech, which is a substantial amount, because conventionally these greenhouses use around 400 liters per kilogram of tomato, so a substantial amount of water.
And in the Netherlands, that is?
Yeah, in the Netherlands around maybe 20 to 30 liters of water.
Yeah.
So mainly going into irrigation, of course, not so much into
in the cooling.
Yeah, in the cooling.
That's the biggest difference.
And we already see that in the high tech we can reduce this number to 4 liters per kilogram of tomatoes.
That's bizarre.
Yeah, that's only 1% of what they are currently using. So that's a tremendous saving.
And that's even less than we use in Dutch greenhouses.
Yeah, that's less than what we use in Dutch greenhouse. Yeah, basically because this closed greenhouse is really close. So all the water you put into this greenhouse remains basically in the greenhouse. So this, it's constantly being reused. Of course, you have to slightly get some water out because there's some buildup of nutrients, and also you have some leakage, of course, because the greenhouses of BOM are perfect, but they are not completely closed, so some water is still leaking out. But it's still a tremendous result, because from this 4 liters you are using, actually 1 liter is in the tomato, because a tomato basically consists fully of water. So actually you are only using 3 liters of water if you really look into the numbers, because 1 liter goes into the tomato itself.
Yeah, of course.
Yeah.
And that's everywhere that's needed for the food.
Exactly. Yeah.
So, but that are quite promising results for the future as well.
Yeah.
I'm also very curious, because what is the use of energy, for example, per square meter? Is that way higher, or what's the result of that?
Yeah, the energy is substantially higher, of course, because basically you are applying air conditioning, and air conditioning in a conventional building already consumes a lot of energy, but in a greenhouse it's even more, because basically all the solar radiation coming into the greenhouse has to be cooled away. So we are using a substantial amount of energy, but we are calculating how much energy we are using, and then we are looking at well, how can you make this energy part sustainable? So by applying photovoltaic cells, for example, or other
solar
means,
or
solar panels.
There's so much sun there, so I would think
exactly. And
that's what I said a couple of minutes ago. In my opinion, there's enough energy available in the world. You can use solar, you can use, well, of course, fossil fuel. We have to use as less as possible, but there are alternatives.
Yeah.
So
that's not the problem.
Energy is not the challenge.
Water is the problem.
Water is the problem. Energy might be a challenge now in the initial investment to get it.
Yeah.
But eventually, on the long term, water is a resource available on planet Earth, which you cannot create.
Yeah.
So we have to be very careful with that. So, in my opinion, that's also economics, feasibility, possibility. Some regions in the world, it's not possible to grow tomatoes because the climate is challenging. And if you have to use some energy and technology to be able to grow there with as less water needed as possible, losing as less water needed as possible, then the initial investment in doing it for the energy part is the only solution if you want to grow there, if you want to be independent.
Yeah.
So I think for the region, and we have a similar question now from Qatar, which is not quite the same as Saudi climate-wise.
It's
even more challenging.
Yeah.
They're also
Why it's more challenging?
Yeah, because the humidity is higher. So this cooling using evaporation of water is not working in Qatar.
And mid-tech is not possible.
Yeah. So
okay.
you can only grow in the winter time, not in the summertime basically. But with this closed greenhouse you can, because then you are applying air conditioning, so you can still cool your greenhouse. Yeah. So there, this technology is vital in order to produce. Yeah.
And for now, would it be profitable for other companies to directly use this, these new developments or these new greenhouses as well?
You mean growers, customers?
Yeah.
Yes. I think if a grower in that region, if he wants to be supplying to the market year-round, he wants to have his vegetables on the market, and he's in lack of water, then the initial investment in energy, I think it's a challenge now, because logistic-wise, there is availability from production from other countries. So financially-wise, that's something that Wageningen University is finding out now in the test.
Yeah.
Really monitoring what's needed in labor and in energy and in water. In my opinion, that's a guess. I think the tomatoes in a full closed greenhouse might be a little bit more expensive, but it's year-round available. It's high quality, and eventually it's for the long term a solution to deal with the lack of water.
Yeah.
And not only that, because it's also, there's another benefit. So it saves on water, you get a higher production, but also you have to apply less pesticides. And pesticide is a major, it's majorly used there. So you can see it in the residuals of the products there. But if you apply a closed greenhouse, you have less insects coming in, or basically no, if you apply a good hygiene protocol.
Yep.
So the quality of the food is much better.
Much better, yeah. So in the whole economics, in the end, for the grower, it will also be very important to brand the products coming from this high-tech greenhouse, brand it differently than the current products. So, really saying, well, not a lot of water is used, or hardly any water is being used, no pesticides are being used, and less area is being used. And I think when you brand these three items into your product, then consumers will also be willing to pay more.
Yeah.
But they will pay more because the quality is higher, of course.
Yep.
Yeah.
So my last question, how do you see the future in 10, 20 years? Are there a lot of these greenhouses there in that area? What do you think?
In the region? Of course, I hope so, but I'm not only hoping so, I am sure. Also there, the climate is changing, it's getting more hot. The water is decreasing, so eventually, if they want to grow there, they need the technology. The request is coming, and that's a very positive upside from the project as it is now. ST Dama project is there. It's functioning, it's operable. There are a lot of visitors, local but also from the surrounding countries, that want to see the technology, that want to see themselves. The showcase, and not just the showcase display, but real visible.
Yeah.
It's real, it's there, it's functioning. So it will create eventually a bigger demand, and the technology is needed to be able to cultivate there. So maybe not a green desert, but a glass desert for the part to be able to turn it green. Yeah, I'm convinced that will happen.
Thank you very much for sharing your story. I really hope that we can hear more about it during GreenTech 2018, because I'm sure you will have new results by then.
Yeah, thank you.
Thank you very much, and see you there.
Welcome.
Thank you. You're welcome.